and welcome back to our weekly series where we try to look at the various different ways in which we can solve machine learning related problems. Now, the idea behind this series, as you all know, is to inculcate the programming practices required to successfully create any machine learning, deep learning application. Now, we will try to follow the question-making methodology for this entire process. Okay, so the first, again, let us have a quick recap because from today onwards, we're going to jump towards a completely different direction that many of you may not be familiar with. So we have our question-making. Now, according to question-making, the first step is actually split into two parts. We have business understanding and we have data understanding. Excuse me. Of course, we have to establish what the problem is and what exactly it is that we are trying to solve. The next step is called data preparation. It's a single step, but it actually has three vital components to it. We have EDA. Excuse me just a second. We have EDA and we have graphical representation. Okay. Then we have data preprocessing. And then we have our feature engineering. Now, these are all very standard processes that everyone must be fully aware of by now. Right? You are required to follow all of these processes no matter which way you go. Okay? So it's very important for you to be able to understand and move in these directions. Right? So, then what is the third phase that we have? The third phase that we have here is known as model building. Now, in model building, we will try various different models. And the idea behind these different models is to understand what are the options available to us. Because there is not just a single shot solution that we can apply blindly anywhere and it will work for everything. No, it doesn't operate like this. You need to be able to have the flexibility to try out different things. Okay? Because these different things is what will help to set you apart. Okay? Right? Then we have our next stage. Now, in the next stage, we will have model testing and evaluation. So here we will try to get the results for a model. Of course, see, you're going to train your model, right? So you want to have a test for it. It's the same principle that follows when we are looking at things such as your school overall learning in your school, right? Even in that case, what do you do? You will do some kind of test, right? And then you will learn a concept, do the test, learn a concept, do the test, learn a concept, do the test. So it is a very simple process that we follow. So the same logic applies to our EDA and model. Okay. Once we do the test, we can, start moving in between these three steps depending on our results. Okay. So after we do all of this, we jump to the fifth stage, which is our model deployment. And what is the idea behind deployment? Why do we want to do deployment? The reason for doing the deployment is very simple. The clients that you're going to be working for, they're not going to be machine learning experts. Right? You could be looking at a singular client, maybe like a company or some individuals, or maybe you're looking at the common people. They're not going to be having the ability to perform and run machine learning applications. Now, if they were able to run machine learning applications, they wouldn't have asked you, right? So that is where our deployment comes into the picture. Now, over the last couple of sessions, we have been looking at various different deployment tools like Flask, Streamlit, etc. Right? These are all frameworks that are available within Python for you to be able to run your deployment applications. Now, the final stage is monitoring and maintenance. Now we're going to start shifting our focus on this stage. We're going to start shifting our focus on monitoring and maintenance. Okay. Now, monitoring and maintenance is a very, very critical aspect of our machine learning project lifecycle. Right. The idea behind monitoring and maintenance is to automate the process. Okay, so let's focus completely first on what exactly is monitoring and maintenance. So, what is monitoring and maintenance? Monitoring means keeping an eye on the application. So, whatever application you're looking at, you're going to be keeping an eye on it. Okay, you're going to be focusing on that application. You're going to be trying to look at how that application is going to work. Okay, that is the task of monitoring and maintenance. Okay, then In maintenance, we will fix any errors we might have. Okay. Now, what is monitoring and maintenance going to focus on? Monitoring and maintenance, the idea behind monitoring and maintenance is we should try to look at the user input. And as the user is pushing in more and more data, the model will need some kind of updation. And that is a standard practice, right? If you think about it logically, in monitoring and maintenance, what exactly it is that we're going to do? We are going to simply have our application retrained. Okay. You have looked at the process of things like saving the models, right? You've understood how we can save the models and such, right? When you do all of those things, you are saving the model which is trained on a specific data. Now imagine your project's life cycle is, maybe 1 year, 6 months, 2 years, 3 years, we don't know the exact time, right? It depends on the different requirements. So here, in this case, do you think that the original model that you trained is going to be relevant in 2 years' time? Let's say that your project life cycle is 2 years. Is it still going to be relevant? No, it's not going to be relevant, right? If you're thinking about this and you are, trying to answer this question, the answer is no. It's not going to be relevant. Okay. So what we have to do is constantly update the model, which also falls under the process of monitoring and maintenance. Okay. So then looking back at our final steps, we have deployment and we have monitoring and maintenance. What we want to do now is bridge this gap. Okay, we have a bit of a gap here, and we want to bridge this gap. All right. So what we're going to do here is we're going to look at a couple of things which will help us. Namely, we are going to be looking at something called Docker. Docker. Now, what is Docker? So, Docker is an open source platform which is designed to automate the process of deployment, scaling, and management of applications. That is what Docker is. Automation of deployment, automation of scaling. Scaling means in upscaling or downscaling depending on the traffic, right? And management of these applications. Okay. So Docker is going to follow the process that we call as containerization. Okay. We are going to be looking at containerizing our application. Okay. So this is my ML solution. I've taken this ML solution and I have deployed it on some, let's say, I've deployed it on Streamlit. Now, this is deployed on my system. What if I want to deploy it on your system? What if you want to be able to deploy this on your own machine? What will you do in that regard? What is the process that you will follow in that regard? The process that we have to follow here is that we will maybe store our data somewhere, let's say like a Google Drive, and share it across to our colleagues who will then take that and they will deploy it. But what if they are not able to deploy it because there is some kind of clash of requirements or some clash of the data, right? There's so many things that could go wrong, right? Now, what if we could we could give a deployed solution that can be run anywhere? And I'm not talking about the application, I'm talking about straight up Python deployment. Okay. So we have already looked at the concept of pipeline. So similarly, we have the concept of containerization, which is the principle behind Docker. Okay. So you have a container here, you have a container here, right? And you have another container here, right? Essentially, these containers exist in a vacuum. These containers, you're not going to be, you know, you're not going to be having any kind of overlap. Let's say I have ML1 here, I have ML2 here, I have ML3 here. I have three different ML applications which are going to be used for different tasks. This is a regression model. This is a text classification. And this is a image processing application. Now, here, it's not just about the fact that these are three different kinds of models. Okay, this was developed 3 months ago. This was developed a year ago. This is sort of like a legacy system. And this was developed 6 months ago. So we have different time frames where these applications were developed. Okay. So in this scenario, we are having three different applications that are developed at different time and they're used for different tasks. Now, because they are different tasks, you might not have a lot of overlap of libraries. But some basic libraries like NumPy or SciPy or scikit-learn, these are usually common across the board. Right? So, what do we need to do here? What we need to do here is we need to keep them isolated. And that is where your containerization comes into the picture. So containerization will help us to ensure that these applications are not having any sort of overlap whatsoever. Okay. So containerization will also take into account all the different libraries that we use. So whatever are the different libraries available to us, we are going to be able to use containerization to isolate them completely. Okay. That way, my regression model ML1 does not match, does not clash with ML2, which is the text classification, which does not match with ML3, which is the image processing. Okay. Now, these containers are also going to be lightweight. Lightweight compared to things like virtual machines. Now, if you have any experience or if you have ever heard of software development life cycles, virtual machines play a very important role in the development of applications because again, you can use different virtual machines for different applications to avoid overlap. But the thing is, the virtual machine is essentially like a smaller computer. So while it is smaller in nature, it is still quite heavy. Okay, we're still looking at maybe 20 to 30 or 50, 20 to 50 GB of data. Okay, we're still looking at the same thing, right? So our Docker images for these machine learning applications in comparison will be a lot smaller, as you will see. Okay, as you will see when we explore Docker practically. Okay, right. So the other thing is that this is a Linux machine. You might have a Windows. Someone else might have a Mac. And Linux has so many different variants, right? Ubuntu, then we have other things such as Red Hat, etc. Right? There are so many different variants. Okay. So what happens when you try to move the applications from one to another part, right? Now there are virtualization available in Python, which makes it somewhat easier, right? Make it somewhat easier to have a cross-platform development. But usually, you know, we will have some issues. So what these containerization will do is it will allow us to simply move in between these different form platforms without having any issues. Okay, it makes it very, very easy to move. And since I am writing some kind of development code and to give uh, I want to give the same code to someone else, it is very easy to do that. Okay, it is very easy to do that with applications like Docker. Okay, so using something like Docker will help us to understand the cross-platform development requirements. Once you have a containerization system, you don't need to worry about something like this. All you need to ensure is that the container software that you're using is available on the host machine and it is available on the target machines. Okay. So, yeah, the final thing here is scalability. Now, if you take a look at all of these problems, you might realize that these are all very, these are arranged in what you can say could be their memory requirements, right? Can I simply assume that my image processing task will probably be the most intensive task? Okay. Let's say that my image processing requires me to utilize, I'm going to use a very standard example here, one GPU. Whatever GPU is available, that is not relevant here. But I require the usage of one GPU. Okay. So what if during, let's say, maybe mm, 12 to 3 p.m., you require greater utilization of GPU resources, two GPUs. But at the same time, 12 hours later, 12 to 3 a.m., you don't require any GPU to run because there is not enough usage of the system. Right? So if you have upscaled it to two GPUs, right, we are going to be struggling with additional costs once we bring it down to once we are don't have the same requirements. So it makes scalability also very flexible. Okay. So now what will be the idea behind in the upcoming sessions? We're gonna explore Docker. We're gonna try to containerize this application. We're gonna try to look at the various different platforms, frameworks, and our libraries which are used for monitoring and maintenance and how we can utilize our Docker application to make it easier for us to do the monitoring and maintenance. Okay. So if you don't know anything about these platforms, right, we're going to be looking at various different platforms such as Prometheus, Grafana, etc. It's part of a monitoring and maintenance framework. So if you don't know what Docker is, if you don't know what Prometheus is, if you don't know what Grafana is, this is a perfect opportunity for you to start following the series again so that you can learn about these different tools. Okay. So from everyone here at 360 Digit MG, thank you so much for all those who have joined in and tuned in today. We're definitely very excited for the upcoming sessions where we are going to explore new tools and how to utilize those new tools. So again, thank you so much everyone and we'll see you same time next Tuesday.